Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with the leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Tom Pruchet, Director of Electrification, Munro Associates. On today's episode, he'll share his thoughts on the current state of battery technology. We hope you enjoy this episode. Tom, welcome to the podcast.
Thank you. Happy to be here.
Excited to have you here because performance is one of the keys that's driving electric vehicle adoption. When consumers get in there and they put the pedal to the metal, it throws you back and you feel the G's, and that's a really big way for individuals to go there. You were there in the early days of electrification. You put it on a drag strip. What was that like the first time that you got an electric vehicle and just floored it?
It was a life-changing event. I actually was a passenger the first time I experienced it. And I was in a Tesla test vehicle when that happened. And it was quite an exhilarating feeling. And as a lifelong drag racer, I kind of had expectations that were exceeded, if you will, by a long shot, to the point where it threw my back out. And as this lifelong gearhead showing off pictures of my car with the front wheels in the air, I didn't have the nerve to tell them that I had to go to the chiropractor after a visit in that car. So yeah, it was an interesting experience, to say the least. And acceleration performance is a relative thing. And when it drags out at more than 1 G for 4 or 5 seconds, yeah, it's an exhilarating experience. So many chances since then. But it's addicting. I'll make an analogy here. Everyone worries and misses the visceral feel of the V8 engine or the combustion engine sound. And I challenge those who have that feeling to listen to an electric dragster and listen to it with headphones with the volume turned up. And you will experience the raw feel of tires ripping the pavement. This is a very interesting sound. It's not like the sound of a V8 engine dumping all this energy out the exhaust pipe where it can't be transferred into acceleration. It is all acceleration, and the tires will squeal the whole way down if you have a powerful enough car. So yeah, it was a life-changing thing for me to watch it that way the first time, and even more so to be in it. So sorry for the elaboration.
No, it's really curious. I read a review over the weekend of the new Ford Mustang Dark Knight, and the gentleman from the Wall Street Journal said, "Oh, it's the rev of the engine," when he went to Cars and Coffee, and everybody just wanted to hear him rev. And he said, "Of course, technology being technology, there's an app where I can just rev it from when I'm inside the coffee shop." And I thought that was really kind of cute because electrification, we don't have that. We have seen some companies that are trying to put the sounds into that, but the electric vehicle can still outperform the Ford Mustang Dark Knight. What is it with the electric vehicles? Is it the battery chemistry that gives it acceleration, or what allows those vehicles? And for all practical purposes, the Tesla Model S is a family car, and it can outperform a Ford Mustang Dark Knight. What allows it to do that?
Well, it's an interesting thing when you amass enough energy to get the range that everybody seems to want here. And when you're talking about a Tesla Model S Plaid, this is 100 kilowatt hours. That's a pretty big battery. And because it's so physically large, capacity-wise, it's easy to achieve a lot of power. The Model S Plaid, being sort of the king of the hill of today, it has well over 1,000 horsepower that it can deliver mechanically to the pavement, but it's enabled by the battery having the ability to deliver that electric power. So that's not always achievable, and the smaller the battery is in terms of energy, the more difficult it is to get that level of power out of the battery. So yeah, it's kind of a serendipitous moment that they have so much energy on board, because it's reasonably easy to get that much electrical power to feed the hungry motors that want that power. So it is a common thing where a motor might be more powerful than what the battery can deliver, and therefore the drivetrain could very well be limited by the battery's performance. So yeah, in the case of the car you mentioned, the battery is a remarkable piece of technology there. It's also interesting for those who might be into this sort of thing that it uses the smallest of the popular cells, the 18650, and a lot of them. So a couple of enablers for that acceleration performance.
How do you see battery technology evolving over the decade? Does it get more compact? Do we still see this consumers demanding performance? Do we see it perhaps getting smaller where you're going to have a vehicle for 50 miles, 100 miles, especially in emerging markets? Or how do you overall see battery technology emerging?
We have no shortage of different chemistries that are coming. I expect there to be an all of the above sort of approach to that. There won't be any super rising stars that fall out of that as the ideal or the main way forward. There'll be a lot of different technologies. So the one thing that is quite obvious to me is the ability to maintain this rate that we are at with electrification. The rollout, if you will, is a very difficult thing to sustain over time with regard to the materials that it's going to require for the batteries to be made. So, yeah, there's a lot of emphasis on a lot of those chemicals. There's a few that aren't very well emphasized in the industry. A lot of people aren't expecting a shortage of graphite, but that's coming. So these different technologies will come out and offer an alternative to the existing NCM, NMC technologies of today. And, for that matter, there still won't be enough of these materials for everybody to get their 100 kilowatt hour plus battery. They will have to right size these batteries for the applications like my own, for example, where I only have a 6 mile commute from work to home. So, yeah, for people like me, we don't need the big battery. Most people will afford a second car for longer range and or rent one. And yeah, I see this being an inevitability here that the cars have to be right sized to the application. We enjoyed the luxury of the first adopters, and we pretty much exhausted all of those. Everyone else needs an actual practical use case. They need a practical model and make it good for them. And part of that will be right sizing the battery. So I see them getting smaller and possibly optional, and maybe eventually something that can be swapped out to a larger one if you find your needs have changed. So yeah, we're looking out 5+ years for that.
Would consumers accept a right size battery now? For a while, I thought it was a 300-mile range for consumer adoption. Now I'm more in the camp of the 400-mile range for consumer adoption. It just seems that the consumers want a mass amount of range. You can read JD Power surveys, you can read Wall Street analyst reports. It just seems that the longer the range, the happier the consumer. And you're describing an opposite potential situation.
Well, that's just it. It'd be ideal to be able to continue to make the batteries larger and larger, and it will remain as such until the materials get to be shorter in supply and more expensive. And then it'll become a very costly feature to have that large of a battery. So while you're right, a lot of people need that sort of range in order to be convinced on their own that electric vehicles are right for them. There's a lot of people who don't have that long of a commute and can live with a smaller battery. Back in the heady days of the Chevrolet Volt, General Motors had a pretty important tagline about 40 miles being the goal for the majority of consumers. And I believe that's still true today. So can we get them a 40-mile battery and, hybridization to take them the longer range? Well, that's what the Volt attempted to do, and it apparently wasn't successful enough. So there's something between 40 miles and the 400 you espouse to as the sweet spot for the average person, and I'm sure it'll vary person by person. But I know for me, I would like to buy a new vehicle with about a 20 kilowatt hour battery, and I would live with a very short range it would have and use it every day for my daily commute.
I was always a fan, I still am, of hybrids. You say you have a 30-mile, 40-mile range on a battery and the rest are gas. And I'll give you an example. Tata Motors, 3 years ago, they introduced the Range Rover Hybrid. And that actually never came to market in the United States, and that got scrapped, or whatever term you want to use. Next thing you know, there's a waiting list for an all-electric. Why in the higher-end vehicles, especially larger vehicles such as that Range Rover, do you think that the hybrids never took off? They never manufactured. Was it the complications around the supply chain? Was it the political pressures that you must go all electric, or why did those hybrids not take off in those high end, large luxury vehicles, in your opinion?
You make the point and the differentiation that these are high end luxury vehicles where you would expect that the consumer could afford it, for one thing, because that's your first answer why hybrids aren't prevailing, is that people don't want to pay for one powertrain, let alone two or three or four. And hybridization brings you multiple powertrains and the complexity and cost that comes with that. So these vehicles, again, a lot of the ones that are on the high end of the spectrum there, people are making these purchases as a statement. They want to believe that battery electric vehicles are better for the environment, and therefore, if they buy them, they make an example, and that example multiplies, and that's all very true. So, could they have made a hybrid variant of those things that would have been successful? I suspect that the buyers of those vehicles had ideals that would have prohibited that from being successful, but not for the same reason that the low end buyer would have, where it would just be too costly or too complicated for their liking. So, yeah, this is really about the ideal. The entire industry moving right to battery electric vehicles almost in its entirety across the board is a good example of what you're referring to as well. Why is that? Well, again, hybrids are perceived as complex, hybrids are perceived as expensive, and nobody wants to spend more money than they have to. So, yeah, jump right to the chase, go right to the battery electric vehicle across the board, expensive vehicles, inexpensive vehicles alike. And yeah, that's kind of a sad thing for me because, again, we could live with a hybrid system that would solve most people's transportation needs, especially the ones we read about all the time, where somebody buys a battery electric vehicle and then finds out the hard way that it's difficult to have long distance trips, cross country trips. Wow, big surprise. Yeah, if you have a Tesla and you have the supercharger network, that takes a lot of the pain away. But if you don't, yeah, there's still a lot of pain. So, yeah, hybrid vehicles, don't count them out, don't count the combustion engine out, but it is certainly falling out of favor with the public and especially the people trying to make a big statement with their high-end machines.
It's falling out of favor, but the combustion engine serves a real practical purpose. The hybrid serves a practical purpose. And the more I study electric vehicles, the more I study the supply chain, I realize how dumb and stupid some people are and how flat-footed we were caught. If you go and you read the statements made by President Xi of China around the Silk Road Initiative, and you read the speeches that he's given, for years he was clearly laying out China's dominance to control the EV supply chain, and then he was clearly laying out the demonstrations around the refining, and you could see that in the speech he made in Indonesia. Several of his vice premiers have made in the Congo region. And then you have China that is an economic calamity. They have the real estate market's collapsing. They're going into a deflationary environment. President Xi is not going to build the economy. He's going to try and let the economy run into the ground to rebuild it. Well, meanwhile, here we are as a world dependent on China for lithium. We're dependent because they control the Congo with the cobalt and the refining. And it seems like we're caught footed in their economic calamity is going to spread to the rest of the world. With all that being said, why, when there was this big shift to electrification, in your opinion, and thank you for highlighting the graphite shortage, which has to be highlighted, why was the attention not paid to our strategists laying out, hey guys, we've got a supply chain problem. We're going to bet the farm on a country that we have no control over? Why?
Well, yes, the bet, as I see it, is that there doesn't need to be an overabundant reliance on China for this if we can pull some of it stateside, or at least the vast majority of it. And the government initiatives have gone a long ways to try to make that the case, especially if you're looking for federal tax subsidies. You need to have content that is increasingly American content over the coming years. So the whole concept here is to onshore these activities, try to build a case for them, build especially a business case. If those materials are increasingly costly, or if the tariffs make them prohibitively expensive to import them, then we will be inspired as businesses to create our own sources for those things. So, graphite has one of the largest supplies here in North America. We're just not mining it. Well, once it becomes expensive enough, we will mine it. I truly believe that the material shortages will keep up in a reasonable way until they don't, at which point there will be lots of alternatives. There's quite a few battery chemistries that don't have to rely on graphite, for a good example, using hard carbon as an alternative. So some of those will come into prominence when the graphite shortage starts to really be painful. And as I said, we will start mining more of these materials as it becomes lucrative to do so. So some of that's already in place, happening slowly and incentivized by the U.S. government, but it needs to happen at a faster pace. So I don't know if that answers your question. There's a reliance there now, especially for rare earths and things of that nature. But I think as economics kicks in here, we will find the wherewithal to get those materials other ways.
We're going to have to do something. This is the fool me once, fool me twice scenario. We learned this lesson with semiconductors. We could thank Morris Chang and Texas Instruments for that and be the reliance on Taiwan. That's been well documented. We're seeing this again. Tesla did, in my opinion, what nobody else did. They built out the charging network. They saw the problem ahead of time. Why did other companies not predict the potential supply chain snags or the problems for consumer adoption and start building those aspects out first? Why was there this giant rush to just build the vehicle and then everything else around it? Oh, we'll figure that out later.
Well, yeah, part of it is rooted in the Tesla effect. Tesla is notorious for being very vertically integrated to the extent where they look for those materials themselves. The other automotive OEMs, not so much, if you will, but they saw that Tesla was leading the charge, and some of them have gotten the memo, if you will. You have various OEMs like GM investing in lithium mining. There's more and more of this vertical integration that's coming in as they finally realize that this is part of the Tesla secret sauce, if you will. The other part of the secret sauce that they haven't got the memo on is the running change, being able to do things quickly, change technologies, battery chemistries, especially quickly. So yeah, the notion of vertical integration is slowly catching on, and a big part of that has now been incentivized by the U.S. government with the federal tax subsidies and trying to Americanize the content, even down to those materials. So it's a work in process. It'll get there.
It will get there. You have to give Jim Farley, CEO of Ford, a lot of credit. He's been publicly documenting his Route 66 trip. And to quote Mr. Farley, he said it was eye-opening.
Yes.
Around the charging infrastructure not working. Here's Mr. Farley, CEO of Ford, and he's experiencing it firsthand. You could make the argument that Mr. Farley should have done that a long time ago, but you do have to give credit to Mr. Farley for actually going out there and experiencing it firsthand. Let's use Ford for example. They have the Mach-E on the market. They have the Ford F-150 Lightning on the market. They're both going to be, and if you look at historical data around the Mustang sales and the Ford F-150 sales, they'll both sell very well for Ford. As those vehicles mature over the years, technology changes. Do you see the battery chemistry in the F-150 Lightning and the Mach-E changing over time?
Oh, yes. You will see, Ford is probably one of the more agile American OEMs with regard to adopting new technology more quickly. They're already on the public record as looking at LFP as an alternative to the more expensive NCM and NMC chemistries that are more popular today. This is an energy density hit for sure. This means that for the same size battery, you won't be able to go as far, but you will be able to charge it more times. You will be able to abuse it a little bit harder and without the safety concerns that might come with the incumbent chemistry. So yes, that's something I fully expect to happen, and it's already in process, if you will. But again, to play catch up with the others that are changing technologies very, very quickly, it's going to be a daunting challenge for all of the OEMs. And as I mentioned, Ford at least already has a good head start looking at LFP as an alternative.
Let's stay on I'm really curious. Let's stay on the F-150 Lightning topic here and make it more broad and let's say pickup trucks in general. Owners at pickup trucks, majority of them haul stuff. They haul boats. They haul a variety of things. They carry large things. Are there certain battery technologies that are perhaps in the lab that are emerging that could allow the individual owner of that electric pickup truck to haul stuff? Because we've all seen where the range degradation, if you're hauling something, goes down dramatically. Are there any things in the labs that are emerging from a chemistry standpoint that could allow that electric pickup truck to have that same range, even though if you're hauling?
Well, we're, on task to try to bring ever greater energy densities to the marketplace, right? So we have the hope of the solid state battery that's going to bring us a huge bump in energy density. Energy density ultimately is what you're looking for to get this sort of range that they're used to. It's no secret that when you load up a gas or diesel pickup truck that it doesn't get as good a mileage, but it doesn't hurt as bad with one of those because there's always a gas station to stop at. So the difference isn't all that much between the electric and the gas or diesel variant. It's just about the infrastructure and how long it takes to charge it and where you stop to get a charge that's sufficient. So yeah, I would ask for a future of higher energy densities that will solve that problem. The other thing that needs to happen too is the consumers need to educate themselves about their use case and understand, what that use case entails with regard to fast fill-ups and, do they really need that? And if they do, maybe they have to have a couple of different solutions for that, not just one that they want. So again, this was, as I mentioned earlier, could you buy the electric truck for 90% of your use cases and then have some 20-year-old pickup truck that is for the exception case where you need to haul across country? That's one way. There's rental of vehicles, but obviously, to get the range they want, you're going to need much greater energy density. And that's going to basically put them on par with the biggest of diesel tanks, if you will. And then again, if they can get the chemistry right, then it'll charge at a faster rate and they'll get closer and closer to the, 10-minute fueling rate that they're used to. So a 10-minute charge is a wonderful goal to achieve. And yeah, the new chemistries will probably get us there.
Toyota's working on that with their solid state battery. The company claims 745 miles of range in 10 minutes. What are your thoughts on that? And I look at this from my perspective. They were the hybrid king. Is this Toyota playing catch up, or was there really a massive big breakthrough and then Toyota's going to have their Prius 2.0 moment now?
Well, it's an interesting thing the way that was worded, and it's often confounding for me personally when I read statements like that. It's difficult to understand what's meant when they make a statement like that. What does that mean? So 700 plus miles per charge in 10 minutes. Okay. That doesn't tell me much about the breakthrough that is their new chemistry. For example, if you have a large enough battery, we talked about this a little bit earlier, when you get to a certain threshold, it's pretty easy to charge at a rate that'll give you lots of miles per minute. But you have to have a pretty large battery to get there. And again, it's just like the Tesla Model S Plaid that wants to discharge really quickly, and it uses a very large battery to do that. If you wanted to get a lot of miles in a very short period of time from a charging standpoint, just have a really large battery, and today's C rates will suffice to get you that sort of mileage. Now, Toyota's whole point is that they're increasing their energy density, but they didn't give you a lot of detail to understand just how significant this new technology is. It's real easy to say something like miles per minute, but without knowing how much the total size that battery is, it doesn't really tell you much. Again, C rate is the part that I hope that the consumer can get themselves educated on. Gross generalization, 100 kilowatt hour battery. If I charge that at 1C, that's about 100 kilowatts. All right, it's going to take me at 1C, it's going to take me a significant length of time to charge this thing as a function of C rate. If I'm at 1C, it's an hour. If I'm at 2C, it's a half hour. If I'm at 3C, it's 20 minutes. If I'm at 6C, yeah, 1/6 of an hour. That's the goal. That's your 10-minute fill up. So the US government's got a threshold that points at that 10-minute charge as the breakthrough that is what everybody needs. So we'll see. Now, the important thing to realize about that is that 10 minutes as a function of C rate is completely independent of the size of the battery. That could be as small as the battery in your phone or as large as the battery in the GM Hummer, right? So 10 minutes is the same regardless of what that capacity is as a function of the C rate. And that's the part that people need to focus on. Is this new technology from Toyota a very high C rate? Is that what they're bragging about? Because telling me in terms of miles per minute doesn't tell me much.
What role do motors play in achieving range?
Motors are a very important part of it. One thing to realize when it comes to efficiency is that all these different things in the drivetrain add up. And more specifically, they multiply up. So for example, if I have a motor that's 90% efficient and I have an inverter that's 90% efficient, those things work in concert with one another. So the 90% efficiency of the motor multiplied by the 90% efficiency of the inverter, that is an 81% efficiency. And that confuses people. It is 90 times 90. And that part of it is not very well understood about the public. The same with gears in the drivetrain. If I have a 98% efficient gear train, okay, I take that 81% efficient motor and inverter I described, and I multiply it by 98, and I have even less than 81. So the same goes through the entire powertrain. You have to look at each individual component. A motor's efficiency is probably the one that is most elusive from an understanding standpoint because it's kind of confusing. For example, if I'm sitting at a dead stop and I'm applying torque to the motor, but I'm not moving, guess what my efficiency is? It is 0. And that makes smoke come out of some people's ears when they think of that. How could it be 0? Well, you're not doing any work. It's not moving. Yeah, so that's if you're consuming energy and you're not doing any work, that's 0% all day. So it starts at 0, and as you start to drive away, it becomes non-zero, and very quickly up in the 5-10 mile an hour range, it becomes a couple of digits of percentage efficiency, and you have to get it quite high in the speed load curve to get to that 90+% efficiency. And this is very much a function of the motor's efficiency sweet spot and how well matched that motor is to the drivetrain, and more specifically to the drive cycle. If it's a city sort of vehicle, then you would like the efficiency sweet spot to be lower in the speed range so you can achieve the maximum efficiency more often. If this is a highway going vehicle, you would like it to be at its efficiency sweet spot at your highway going speeds. So again, matching the use case to the application. Hopefully people will do their homework and understand whether their vehicle is designed well for their use case or not.
Does the design of the motors go all the way down to the in-wheel motor technology as well?
Well, the in-wheel motor technology that we see mostly, and there's lots of it coming, for the most part, what's been in the news has been direct drive. So this means that the motor drives the wheel directly and there is no gear ratio. So they have the added advantage in that there is no gear to have the loss across. I made a hypothetical example of a 98% efficient gear train. Well, that's a 2% loss. So if you don't have gears and you had a 2% loss with gears, then you get a free 2% by eliminating those gears if you can do it. Now, the reality is that there is no fixed efficiency of a gear train. Anybody that tries to tell you that it's a fixed efficiency is not telling you the whole story. Because it has a map, just like the motor has a map, and it has an efficiency sweet spot like the motor does. But it's a very well kept secret. People don't get to know much about the efficiency sweet spot of their gear train, let alone how well that's matched to the rest of the system. So yeah, the wheel motor gets a bit of an advantage if it's a direct drive system because it doesn't have losses associated with the gears, and that could probably be as little as a 2% advantage, or maybe as much as a 10 or 15% advantage in worst case scenarios where there's lots of gears that mesh. So yeah, a lot of modern day vehicles are measured on chassis dynamometers, and they measure power at the wheels and infer the power at a theoretical flywheel, and then they add this magic fudge factor of 15% as the losses of the system. That's a high amount of losses, but it is pretty commonplace in chassis dynamometer assessments to assume you'd have as much as a 15% loss in the drivetrain. Now, I would argue most of the transverse mounted applications of today, you are in the 2 to 5% loss range, but that's still quite a bit of energy that can be reused in other ways, and it translates directly into additional range.
How about also performance? Can that translate into performance as well as range?
Exactly right. If I don't have the losses across a gear train and I can get enough torque to accelerate the vehicle without the gears, then yeah, I can translate that into corresponding improvement in acceleration performance by not having the losses of the gears. But it is especially challenging. This means you need to be able to create the torque at the wheel that's necessary for the acceleration goals. This is kind of a very confusing thing for people. If we're used to measuring the torque at a flywheel somewhere on an engine, well, first of all, most of these have 2 engines now, so which flywheel are we talking about? And then from there, the front often has a different gear ratio than the back, so now it becomes really important as to which one we're talking about. But again, to infer the torque across a gear ratio doesn't tell you too much. I don't get to know by how many pound-feet or newton meters an electric motor has, how that translates to acceleration performance until I know the gear ratio between that motor and the wheel. And in the case of a direct drive wheel motor, there's no mystery because there's no ratio at all. And yeah, they must make that torque natively. And it's a significant amount of torque, and it just causes a lot of confusion. So I made a weird assessment myself back in 2010 when the first e-tron was shown around the show circuit. Everybody was just falling all over each other about the 3,200 Newton meters of torque it had. Just sounded like a great deal of torque until anybody did the math and realized that that's not much torque at all when you consider what it would have needed to be at the flywheel if it had one. So again, it's easy to get confused between wheel torque and theoretical flywheel torque. And the sooner we start talking more about wheel torque, the more sense it'll make and the better we'll be able to make sense out of it all with regard to, how does that relate to acceleration?
This is getting fascinating. I'm going to add another layer onto the motor technology. Do solid state batteries outperform lithium ion batteries from a performance standpoint? If you want to go off the line, can one battery perform better than the other from a performance perspective?
This gets into the C rates. All right. So again, if a new battery chemistry has a proclamation of a higher discharge C rate, then this means I don't have to have as much energy to be able to get to the target acceleration performance. So certainly if the solid state chemistry that you're referencing in theory has a claim that it can do high rates of discharge in terms of C rate, then yes, it's kind of the holy grail. We won't need to have 100,000 watt hours of energy to be able to get to the 1,000 horsepower target. If you took the Tesla Model S battery and you made it half the size, I would expect you to get half the acceleration performance, or at least half the power that enables acceleration performance. But with a higher C rate battery, yeah, you could have a much lighter weight battery, still get the peak power you want, and not have to carry the battery luggage. So it'll be a less heavy scenario when you're done. It'll be quicker accelerating because it's lighter.
How about from a shelf lifetime? Does the solid state theoretically last longer than the lithium ion from a shelf life perspective, or does it depend on how you're using it? If you're going up on a supercharger 0 to 100 every day, no difference, or what does it look like from a shelf life perspective?
Well, again, there's lots of solid state chemistries that are coming. I would not try to aggregate them all into one category. I would look at each of them on their individual merits. But certainly, I know that as they try to roll out the solid state technology, there's an underlying purpose behind it all, and they're trying to solve a few other things while they're at it. So the underlying purpose behind solid state is to get rid of the flammable electrolyte. Only thing crazier than taking a bunch of energetic metals and subjecting them to this sort of abuse would be to put all those metals surrounded by a flammable liquid, which is what we've done today. So get rid of the flammable liquid, and yeah, now you can have even more exotic metals inside there. And it's a mixed bag of what could come out of that. Everything from what we hope as an improved safety because we don't have the flammable electrolyte. But while we're at it, can we up the energy density volumetrically and gravimetrically? Can we increase the cycle life? Can we get that high C rate for both discharge, so we can have smaller batteries for high performance applications, and in charge, so we can have our fast charge, our 10-minute charge, or something better?
Staying on batteries, what are your thoughts on lithium sulfur batteries?
Lithium sulfur has been around for a while, but they haven't been able to make it work. But recent developments make it look like it's quite feasible, and it's one of the alternative chemistries that we're going to see as part of the all of the above solution we're going to need. So I have high hopes for it. It's particularly exciting for me because of 10C plus discharge and charge rates. So this is even better than what we were looking for with the 10-minute charge. It's probably important to understand why the 10 minutes doesn't get you to a full charge. That's confusing. But when we get to the last bit of the charge, we can't charge at the super high rate. We have to taper the charge off, or we will exceed the voltage that the cells can get to. So generally, when we start talking about fast charge, it's about getting to 80% or so of the capacity, and that's the majority of it. But everyone wants to know why I can't get the last 20% the same way. And again, you have to taper it or you'll exceed the cell V max parameter. So anyway, I don't know if that helps, but yeah, solid state is solving a lot of problems all in one go, but don't treat it all as one sort of commodity any more so than you would EVs as a general category. If there's anything consistent about EVs is that they're all different. So same with solid state.
And that's where we need the consumer education to come in. You get the person screaming, "You're on the charger! I can't charge as fast! Get off this charger!" I own an EV. You've seen people go crazy, and they don't understand that it has to taper off. They get an idea in their head, and they go full-blown crazy. It's just we have to have the education around the EVs to what's possible with an EV and what's not possible. If you want to, we have to set expectations with the consumer. We didn't do that with the supply chain from the supplier's standpoint. We're not doing that with the consumer, and hopefully will change. So the EVs are populating 10% of all global sales last year were EVs. Okay, so they're all in the market. We're seeing what happened in China with fields. Bloomberg's report, just fields of these cars just sitting there rotting, essentially. We have Redwood Materials here in the United States that's working on recycling. Is recycling what's going to happen at the end of the day to these vehicles, or is something else going to emerge that's going to help to dispose of these vehicles when they're done with their shelf life?
Well, in the beginning, when I got into this business, I had a completely different view on what would be the successful recycling program of the future. I thought, mistakenly, that the best battery would be the one that you could tear apart down to the individual components and then repurpose those components. And that would be just a wonderful thing. If 90% of the battery cells are past their useful life, well, can I at least keep those other 10%? But, recent trends have certainly caused that to not be the plan, if you will. So we had a pretty big eye-opener here at Munro Associates when we tore apart the Model Y structural battery pack last year with its 4680 battery cells. We found that pack to be completely disposable, if you will. And the only real way to recycle that thing is to throw it in a shredder. So, okay, is that the future? And it is increasingly looking like that's the case, meaning that they have such cost advantage with this, I will call it a disposable battery approach, that everyone else is aspiring to do the same. So will you be able to achieve some level of modularity to be able to reuse more of the components? The argument would be in that structural battery example, you can still reuse it, but it has to have the failure mode that it just doesn't have enough capacity left, and that's the reason why it's no longer useful for an automotive application. It's still perfectly useful for stationary power application or many other uses. That is, with the exception of if it has some sort of malfunction going on. As soon as there's a malfunction as a cause for its demise, then yeah, that one's going to the shredder. But if it's just at 80% of its original capacity, you can reuse that thing for a long time. So it's a different mindset that says shredding these things are the way to go, but the cost advantage is clear, and the recyclers have lined up to take on that business and try to bring it back as near to the battery manufacturing sites as possible so that we can feed back into the manufacturing process what is this rich ore of materials extracted from recycling, and richer, I might argue, than the stuff we can pull out of the ground. So hence why it'll be so important to keep this juggernaut going. We're going to need to be recycling batteries just to be able to feed the manufacturing process.
Was that the Tesla Model Y that Munro Associates showed at SAE's WCX? Was that the teardown that was on display?
That is one of them. Yes, we had two Model Ys that looked very similar to one another here. One of them had the structural pack, one did not. They were both the same color. But the one with the structural pack was very clearly different in that the pack came out of the bottom of the vehicle with the seats, the carpeting, and the center console still mounted to it. So very clearly different than the previous Model Y that looks very similar from the outside. That Model Y, had a normal floor in it where the seats mounted and carpeting was on top of that, and the battery would drop out through the bottom. So yeah, we have that on display as sort of a stark contrast to what all the others are doing today with their removable batteries and their modularity. That modularity extends not just into the electrical architecture, but also in the form of modules that are electrically and mechanically removable from a battery, entertaining the idea of being able to swap those modules out. While that may or may not be practical as the vehicle gets higher in mileage, it's certainly an ideal and certainly something you want to have as an option early on, like the startups of today have with new battery technologies. They would really appreciate having the modularity and being able to replace things as a subset of the total battery. But when you make that commitment to the structural battery, it's all or none. It either works or it doesn't. And if it doesn't, it goes to the shredder. So, that battery had the electrical architecture of modularity that we're used to, but there is no physical way to remove big groups of cells. And the recycling is as I described it. Shredder is your friend.
Do you feel that it's designed that way? Is that from a cost cutting standpoint of why it's designed that way, or is there another efficiency that it's unlocking?
There was a number of different things that gave that platform an advantage. The new cell that it used, the 4680, was a very inexpensive cell to make. It reduced the number of cells that were necessary in parallel. It reduced the number of welds. It reduced the complexity of the pack by a significant amount. And while it didn't achieve its energy density targets in its first iteration, the interwebs rumors have it that they've done so in subsequent iterations. And that's probably an important lesson for people to realize. We tore that vehicle apart a year ago. It was state of the art. There's been 2 iterations of that same thing since then. So how many automakers would have taken on 2 major changes to a battery technology in less than a model year? So kind of gives you a flavor of how fast that technology is moving. So yeah, the cell was another big part of it that reduced cost, but overall the cost reduction from reduced welds and reduced complexity is significant enough where I think it's compelling, and you're going to see a lot of 46 millimeter cylindrical cell technologies coming in the future to try to expand on that and make it an even bigger bang for the buck. So again, this is 46 millimeters in diameter. It's 80 millimeters long as a 4680 in the Tesla, but we are looking at 4690s, 46 120s, much larger format cells yet that will take advantage in very similar ways, and then some.
Tesla's continuing to push the industry forward from an electrification standpoint. You keep mentioning shredders and shredding. First thing pops into my mind, waste management, the world's largest recyclers. When do these world's large recyclers say, wait a second, there's a huge opportunity in here? When do they jump in with 2 feet? When is Mr. Huizinga is no longer with us, but when does the heirs to waste management, Mr. Huizinga's heirs, when do they jump in and say, waste management's here?
Well, you would think that they would be a dominant force in the industry, and I would expect them to do that. I would expect them to be motivated by other things as well, and that is the conventional way that people tend to dispose of lithium-ion chemistries now isn't very friendly to their waste management trucks. It's not very infrequent that a truck catches fire, and as they dump it all out onto the pavement to put it out and figure out what went wrong, quite often the ignition source was a lithium-ion battery that got compacted unnecessarily, and bad things happen when that occurs. So they may be inspired to take this on just to try to minimize the occurrence of safety concerns on their own transport vehicles. So I wouldn't rule them out, and I would expect them to come in with a great vengeance to try to take more of that market share. But don't know much about what they're doing today.
One thing, putting on my Wall Street hat, they're going to do something at some point. I'm not going to put a timeline on it, but at some point we're going to see a press release with an announcement that they built something, they bought something, then they moved into this space. EVs are driven in all conditions. They're driven in snow, they're driven in rain, they're driven in floods, they're driven in hurricanes. And just like traditional cars, flood damage occurs to electric vehicles. They have to get salvaged. If a electric vehicle is involved in a flood damage, can it still be recycled, or what does that look like?
There's a lot of different ways that moisture can get into a battery pack. There's ways that people think that it would fail, and then there's the ways that it probably fails more frequently. So what is that? You have electrical connectors that plug into the battery. You have coolant lines. They're usually liquid cooled. You have seals that just seal the battery from the ambient environment. There's usually a couple of different types of seals. There's the mechanical seals that everybody's used to. It's kind of like a gasket, if you will. But there's also seals that are related to simply trying to equalize atmospheric pressure. As you go up in altitude and down in altitude, you have to compensate for the ambient pressure change. So there's a small vent in there that uses a Gore-Tex patch that allows air to transfer without moisture, and that's one of the vents that could fail. The bigger vent is one that happens as an exception when you have a battery problem where it releases its internal pressure. There's a larger valve that usually is part of the battery design that allows you to vacate that pressure very, very quickly. So there could be as few as one or two of those, or as many as 20 of those big vents, depending on the manufacturer. And each and every one of those is a potential leak source. The two vent types that I just described, those are probably the biggest leak prone items. The gaskets, the sealing of the clamshell, if you will, that holds it all together, those are pretty tight. I don't expect those to leak anytime soon. The connectors, our IP rating system for connectors right now, it doesn't support the use case of a deep submersion for long periods of time. Look up IP ratings, look at their classifications, look at what the high voltage connectors of today can do, and you will find that there's kind of a shortcoming. If I want to be able to submerge my vehicle in 2 meters of water for 5 days and have it survive, well, it would start with designing it with components that are rated for that purpose. And we don't have a rating that's like that. There is no such rating that gets you there right now. So I expect that to change in the near future if we want to solve that problem.
Well, we do know that electrification and electric vehicles are going to continue to change. They're going to continue to evolve. That's the one thing that we know. Tom, in your opinion, what is the future of electrification?
Well, electrification, I've just spent the last 17 years of my life solely dedicated to it as a career path. But this, I should say with full disclosure, came out of many, many years as an automotive enthusiast, a drag racer, if you will, combustion engine tuner, analyzer, lots of different hats I've worn. And then when I went all in on electrification, it took me a good 15 years to realize that it wasn't the be all and end all. This is not about saving the planet just with that alone. A lot of people have a hard time with the whole saving the planet thing, but once they cross over and realize that this is a real thing that we need to do, you look at electrification, it is not the only solution. We need, again, that all above solution. Just like we need for battery chemistries within electrification, we need to be able to have alternate modes of transportation beyond electrification as well. So that is the fuel cell, which is basically a range extender for an electric vehicle, and that is also hydrogen combustion. So, alternative fuels are soon to be a thing, everything from the syn fuels all the way to so-called carbon neutral fuels that are derived from sequestered carbon dioxide, right straight up to burning H2 directly. And that's despite its many colors. If you read about the colors of hydrogen, it's a rather frustrating thing. It reminds me a lot about the days when people say, your electric car runs on coal, so it is evil. Well, wait a minute. I can take my electric car and move it across town and it's plugged into nuclear. Is it still evil? No. Okay, so it wasn't the car's fault. So it's not hydrogen's fault that people get it from nefarious sources. Eventually, those sources will clean up and the technology will still be there and it won't be the evil thing people say it is today with all the gray and black and brown carbon that is so popular today. So, yeah, I see it as all of the above, and I see hydrogen combustion to play a key role in that, especially for long distance travelers that don't want to carry around a big, heavy battery everywhere they go. This is your Class 8 line haul, long distance trucks. This is a lot of other vehicles that have sensitivity to the need for long range without the desire to carry around a huge, heavy battery everywhere they go to do so. So, I don't know if that answers it, but that's my view on it.
No, but you are correct. We do need a multi-pronged approach. There's not a one-size-fits-all solution. It's a multi-pronged approach with multiple solutions for multiple use cases. Tom, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Well, global warming is a tough concept. And I know all the players. There's a lot of folks that still believe that, the planet isn't warming. And then those who do see it as warming, they don't want to believe that the humans are causing it. And then there's a subset of those who say, well, even if the humans are causing it, can we fix it? Should we fix it? Isn't it some sort of divine guidance that's making it the way it is now? And, all these things are real. But if we could just get to the point where the planet's warming and we have the ability to affect it, everyone would understand the urgency about the electrification movement and the alternative fuel systems that are going to come to replace our gasoline and diesel vehicles of today. So look at it, be honest with yourself. You can either be part of it or you can be part of the reason why we have to do it. And it's your choice. So that's what I hope people do. This gearhead here believes we need to save the planet, and electrification is a very important part of that. It's just not the only important part of that.
It's not the only important part, but it's also a lot of fun to race an electric vehicle down the track, and you've proven that time and time again.
Indeed, check out some of these dragsters that are lucky enough to go on the track by themselves and have the cameras just tuned into their tires and their gear noise, and in some cases old school brush type DC motors with sparks flying and brush holders melting, and all that stuff is a lot of fun. It's just a different way of experiencing acceleration performance, and I would say it's equally addicting, if not more so.
There's nothing wrong with either way. Today is tomorrow, tomorrow is today. The future is electric. Tom, thank you so much for coming on SAE Tomorrow Today.
My pleasure. Thank you.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we are joined by Sam Loesch, Head of Policy and Public Affairs at Wabi. He'll share his insights on policy and workforce development in the world of autonomous trucking.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.